All right, so this lesson 11.3 is about linear inequalities in two variables. And so we're going to look at an example of a linear equation and then use that to kind of launch us into looking at linear inequalities. So if I asked you to graph this equation right here, you might do a couple of different things. You might put it in Desmos and get 2 points and graph it. Or you might graph the y-intercept at -3. Which is what I'm going to do because it's just a little quicker than me pulling up Desmos. But either way. And then you might rise and run with your slope. So from here, my y-intercept is -3. I can go up 2 over 1, and I can put a dot right there. And then I can go up 2 over 1 again and put a dot here. And I could do that as many times as I needed to get where my line needs to be. Okay, so once I get enough points on there, I can graph that. Just connect the line with that. Just like that. So there's my line. Now, if they ask us to tell what points satisfy that equation, then all we're going to really do is look to see if those particular points exist on that line that I've just drawn. So I'm looking at 5, 3. So I'm going to go over here to 5, 1, 2, 3, 4, 5, 1, 2, 3. My line does not go through 5, 3. So this does not satisfy my equation. Then I'm going to look at 2, 1. 1, 2, 1. It does go through 2, 1. This one's good. Then I'm going to look at 0, 0. Well, 0, 0 is right here. Does not go through 0, 0. So 0, 0 does not satisfy the equation. Now, for an equation, the only things that exist for that equation are specific x's and y's that are on the line. A single pair of points, x and y, that exists on that line. But for an inequality, it's a little bit different. So take a look at this inequality right here. The graph of that inequality is going to be very similar. Well, let's not talk about the graph yet. Let's test to see if, without a graph of the inequality, if these ordered pairs will satisfy this. So if I were trying to see if an ordered pair would satisfy an inequality, I could substitute the values for x and y and then see if the inequality is still true. So what that means is to test 5, 3, I would say put 3 in for y. It's less than or equal to 2 times 5 minus 3. Then I'm going to evaluate this side. 2 times 5 is 10. 10 minus 3 is 7. And I'm going to look at what I have. 3 is less than or equal to 7. That's true. 3 is less than 7. So 5, 3 satisfies that inequality. I can test 2, 1 the same way. I would put 1 in for y. Put 2 in for x. So 2 times 2 minus 3. Then I end up with 4 minus 3, which is 1. I don't have enough space right there. I'm going to come up here. 1 is less than or equal to 1. Well, 1 is less than or equal to 1. So this is also true. Then I test this one. 0, less than or equal to 2 times 0 minus 3. Evaluate that. 2 times 0 is 0. 0 minus 3 is -3. 0 is less than or equal to -3. That is not true. 0 is not less than or equal to -3. So 0, 0 doesn't work. So for this situation, both of these points satisfied that inequality. And I can test those again by plugging in the x and the y for x and y in the inequality and then testing to see if it's true. 5, 3, 2, 1, 0, 0. So if you're going to graph a linear inequality, you graph the line the same way you would graph the line for the equation. So this inequality is almost identical to the equation that we just did. So I'm going to put points in the same spot that I did on the last one. I'm going to put 1 at -3 on the y, because that's my y-intercept. I'm going to rise 2 and run 1 and put other points down. And we're going to look at the graph of this. So if I'm graphing this, y is less than or equal to 2x minus 3. I'm going to put my line here. Now, when we're graphing inequalities, and we'll write this down on or see this on the next page in just a minute. We have to look at our symbol because our symbol is going to determine the type of line that we have. If the symbol has an equal to bar, we use a solid line to graph it. If the symbol does not have the equal to bar, we use a dotted line to graph that particular thing. So for this one, we're going to use a solid line just like what we had on, whoa, that was totally not my line tool. Just kidding. Thought I clicked the line tool, but I never did. Anyway, draw my solid line right here. Like that. And we'll reposition it so it's actually on the dots like it's supposed to be. There we go. Maybe. Yeah, it's not that difficult. I'm just struggling here with this weird stylus. Okay, there we go. So there's my line. I've made it solid because of the equal to bar there. But when you graph an inequality, not only do you have to graph the line, but you also have to shade one side of it, because what you end up with is a boundary. This line represents a boundary where on one side everything is true and on the other side everything is not true. So when I see that y has to be less than or equal to this stuff, I need to think about on my y-axis what would be less than the y-intercept I currently have. So if my y-intercept is right here, then less than that would be anything more negative than that -3. So -4, -5, -6, -7, everything down here. So when I shade, I'm going to shade this side of the line for that reason. So I'm shading down below it because I want to show less than. If I shade this part, I'm shading everything on this side of the line. The line is the boundary, so everything on this side of the line gets shaded. What that means is that every point that exists within this shaded region is a solution to this inequality. So if we think back to those points that were on the other page, and we had found, or the top of this page, I can't flip back because it won't record what I'm doing if I flip back and forth. It's kind of weird. But the points we looked at were 5, 3. So let's look at where 5, 3 was again. And we had decided that 5, 3 was a solution to the inequality. So if I look at 5, 3, 1, 2, 3, 4, 5, 1, 2, 3, that point is right there. That's in the shaded part. That's a solution. 2, 1. 2, 1 is on the line. That's a solution. 0, 0 is not in the shaded part and not on the line. That was not a solution. So when we're looking at trying to identify solutions to linear inequalities, that's what we're going to be looking for. We're looking for, does the point exist in the shaded area or on the line, or does it exist in the other space? All right, so this one is very similar, but not exactly the same. So if we were going to test points in this one, just like we did in the last one, we could put 3 in for this one, 3 in for y, less than 2 times 5 minus 3. 10 minus 3 is 7. 3 is less than 7. I'm testing the point again. 3 is less than 7, so this satisfies the inequality. Let's test the next one again. 1 less than 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is 1. 1 is less than 1. 1 is not less than 1. 1 is equal to 1. And this inequality does not have an equal to bar. So this does not satisfy the inequality. That is not a solution. If I put 0, 0 in, 0 is less than or equal to 2 times 0 minus 3. 0 less than, I said equal to, but it's not. 2 times 0 is 0, minus 3 is -3. 0 is not less than -3. So 0, 0 is also not a solution. So from these three, the only one that is a solution is 5, 3. Now let's graph that one, and I'm going to show you something a little bit different about the way we graph this one. So to graph the line, we're going to do the same thing we did on the last one. We're going to put points at -3, or put a point at -3 on the y. I'm going to rise 2 and run 1. And do that over and over. That point did not get where I wanted it. And again, you put as many points as you want to on there. And then we're going to connect that with our line. Now, what we have to think about with an inequality is the symbol here. So this time my symbol does not have an equal to bar, which means I no longer have a solid line situation. I need to be able to do this with a dashed line. So I'm going to create a dashed line here. I cannot draw a dashed line with this program, so I'm just going to have to do the best I can freehand in my dashed line, which is going to be probably awful. Look, it's awful already. I need to start it. We're going to try here. Let's see. Y'all can't even. Y'all, I would never tell you to graph a line as imprecisely as this. That's really awful. Yeah, so that should be a straight line. It's not, but it should be going through those points, but dashed. And it has to be dashed. I think I'm going to do, that's good. We'll do it like that. I can kind of correct my dashes. But it has to be dashed because it is not equal to. What that means is that any point that falls on this line does not exist or does not satisfy the inequality. I'm going to try this. I'm trying to make this look better, y'all. It might be making it worse. Okay, that's not too bad. We're going to pretend like that looks amazing. Okay, so that's my line for that inequality. It should still have... What just happened? Okay. It should still have arrows on the ends because it does continue to go. Because y is less than those values, remember our initial y-intercept was at -3. We're still going to shade on the side that is less than that y-intercept. So below it, because it's less. Which means any point that is in the shaded area would satisfy the inequality. So if we think back to these points, 5, 3, 1, 2, 3, 4, 5, 1, 2, 3 is in the shaded area. It was true. 1, 1, nope, 2, 1, sorry, is on the dotted line. It is not part of the solution set if it's on a dotted line. And then, of course, 0, 0 was right here, and it was not a part of it either, which is how those answers came about. So we can graph them. We want to make sure we use the right kind of line to graph, and we're going to have a note on that on the next section anyway. And then we want to make sure we shade in the correct direction to show everything that could be a solution. Now, Desmos will graph these for you, and I'll show you that real quick before we move on. And they'll even shade them the correct direction for you, which is super cool. To type that in, you just do y less than, don't do double y's, that's silly. Y is less than, what was the thing again? Move Desmos. 2x minus 3. So notice that Desmos does put your dashed line, wrong button, your dashed line, and it shades below that point on the y-axis and everything to that side. So if you were looking at trying to decide if something was a solution, you could graph it with Desmos, and then you could zoom out and look at anything that exists within that shaded area or anything that exists on the line if you're looking for that particular thing. So you can graph in Desmos like that, but I wanted to show you how to do it by hand because I really wanted you to be able to focus on whether the line was solid or dashed and which way the shading needed to go. All right, so here are the steps to graphing linear inequalities. So they tell you to rewrite it as an equality statement. That doesn't matter to me. We don't have to worry about doing that. We do want it to be, if you're going to graph it by hand, you want it to be with y on one side by itself. If you're going to graph it using Desmos, it does not matter. But you start with step 2, graph the line itself, which is the boundary of the solution region. It's going to be on one side or the other will be your solution. Make sure you pay attention to whether your line is solid or dashed. So if it's less than or greater than, you do dashed. If it's equal to, you do solid. So graph the equation, determine if the line is solid or dashed. And then I don't do this fourth step either with choosing a test point. So I'm going to change the way that's written. So we're not even really worried about this first step either. So graph the line, determine if it's solid or dashed, then shade above the y-intercept if it's greater than or equal to, and shade below the y-intercept if it's less than or equal to. So always choose which side to shade based on where your y-intercept is at and whether you need to go above it or below it. So these are going to want you to graph them. I don't mind if you graph them with Desmos or if you graph them by hand. It does not matter to me. I'm going to just look at Desmos and do it because that's accessible to you. So if we were going to graph this, we would do y is less than 5 minus 3x. And so we would create our line exactly the same way that we created the lines for normal equations. So in this one, I have a point at 5. My x-intercept is not pretty, so I'm going to have to find another point other than the y-intercept at 5. But I have my y-intercept at 5, and if I keep going down my line, here we go right here at 1, 2, I can put another point. So I'm going to put a point at 0, 5, and I'm going to put a point at 1, 2. And that's going to give me 2 points I need to graph this line. So 1 point at 0, 5. A point at 1, 2. And then I can do more if I want to. There would be more points available in Desmos. Because I don't have a line tool to be able to draw this the way I want to, I am going to do more. So those are all the points that I can fit on this graph. I look at this after that and I look at my symbol and I say, okay, I need a dotted line. Or I look at the fact that Desmos gave me a dotted line. And so I'm going to create a dotted line there. Again, if you have access to a ruler, use one. Don't let your graph look sketchy like mine. And then put arrows on both ends. And then I have to shade. I need to show that y is less. So I'm going to go on my y-axis to my y-intercept. And I'm going to think about where my y would be less than where that point is at. So if that point is here, y is less than that if I move down. So I'm going to shade below that point. Below that point puts me on this side of the line, so I shade in this whole side. And that's that. I have now graphed my inequality. Let's go back to Desmos and graph the next one. 3x minus 2y greater than or equal to 6. 3x minus 2y, 6. Okay, so there is, let me see if I can bring this to the front. There's my line for that one. So for this one, I've got a solid line. Both of my intercepts are nice and pretty. I have one at, my y-intercept is at -3. My x-intercept is at +2. So this one's going to be really simple to graph. I'm going to put a dot at -3 on the y. A dot at +2 on the x. And then if I want to make more dots than that, I can. Because this one just needs a solid line, I'm not going to. Because I can just draw a solid line with my tool here. But if you want to put more dots, you can pull more dots from Desmos and do that. But for me, I'm just going to do like that, and then we'll grab the other end of it. Like that. And then I'm going to shade. Now this one, because it's not in slope-intercept form, I can't choose where to shade based on the y. So I'm going to just look at my Desmos, and it's shaded under it. So I'm going to shade under it as well. So a solid line for this one because of our equal to bar. We shaded below because that's what Desmos did. If we had rearranged this into y equals mx plus b form, we would have found that y was less than whatever they gave us, or whatever our answer ended up being. And so we would have shaded under anyway. But Desmos will do that kind of stuff for you. You don't have to focus too heavily on learning that part of it. All right. Here's one for you to try. So pause it, try to graph this one, pay attention to what kind of line and where to shade, and then come back and see if you were correct. Now, you may not have graphed this many points. You might have just grabbed a couple from Desmos, and that's fine. So I graphed it starting on my y-intercept at -1. And then I rose 2 and ran 1, rose 2 and ran 1, so on. But once I've done that, then I'm going to connect it. Now, because I don't have an equal to bar, I'm going to use a dashed line. And y'all know this is going to be sketchy, but we'll do the best we can. Like that. And then to shade, I need to show that y is greater than that. So if my point is here, my y-intercept, greater is up, which puts me to this side of that line. So above it is this way, which puts me on that side of the line. And again, you shade everything on that side. All right, that wraps up graphing linear inequalities.